Hey guys, I'm just going to make a quick video on these problems. So I'm skipping the first section, but other than that, there's about one problem, maybe two from each section. So take a look at the list of numbers, and if there's specific ones you need help with, you can always just skip around in the video to those, or just watch the whole thing through just for a little refresher. But I'll be going through 7, 11, 12, 18, 20, and then 24 and 25. So I'm going to jump right down to number 7. So number 7 says to solve each equation, remember to check for extraneous solution. So first thing, just as a reminder, extraneous solution is when you get an answer that makes the denominator equal to 0, because remember we can't divide by 0, so that's what we're checking for at the end. But let's see if we can go through this process. The first thing I want to do is get a common denominator, because once the denominators are the same, I can just worry about the numerators. So if I factor this, I notice that an x can come out of both of these pieces. And then this is the same thing as this was, so it's going to have an x and an x minus 4. Well, when I look at this, I notice that these two have the same denominator. This has a piece of these denominators. It just needs an x. So I'm going to multiply this by x, and I need to multiply that by x as well. So if I simplify this, now I'm going to have an x over the common denominator minus 6 over the common denominator equals 1 over the common denominator. Well, in class, remember, I gave this example and I said, okay, well, what makes this a true statement? And we said, well, 2 would solve that. So then I asked you guys the question, well, what if I throw in a denominator like 5? 2 is still the solution to that. So once I have a common denominator, I can actually ignore the denominator and just worry about the numerators. So that's what I'm going to do here. I'm going to say, now that I have a common denominator, I just need to figure out I'm going to make the equation x minus 6 equals 1. I'm just looking at the numerators. Well, what makes that true? I'm going to add 6 to the other side, so my answer is that x equals 7. Now remember, I'm supposed to check for extraneous solution, so I need to make sure that 7 is not a 0 of the denominators. Well, 0 would be a 0 for x, 4 would be the 0 for x minus 4, so that's my solution. Okay, so that's number 7. Let me go on to number 11. Okay, so these problems are all about domain. Remember, domain are all of the real numbers that you can plug in and get out a real number. So I'm looking for problem spots. If I can identify the problem spots, I'm just going to take those out. For all of these, there's no radicals, no square roots. So I'm really just trying to figure out, is there anything that makes the denominator equal to 0? Because I can't divide by 0. So let's start with number 11. I want to figure out, is there anything that can make this equal to 0? Well, I'm going to solve it. I'm going to take the square root. Well, if I simplify this, the square root of 16 is 4, but because it's a negative square root, I want plus or minus 4. That I comes from the square root of the negative 1. Oops, sorry, guys. So I want to figure, are there any real numbers that make the denominator 0? Well, no numbers. And there's no real answers, so that means that there's no real problems for the denominator. So if there's no real problems, then that means everything is okay. So my domain is negative infinity to infinity because I didn't have any problem spots, or I didn't have any real problem spots. Well, now let's look at number 12. We want to figure out, is there anything that will make this denominator equal to 0? I have options. I can solve for x or I can factor. And I realize when I factor, or if I solve, I get problem spots at 3 and negative 3. Because if I plug in 3, if I plug in negative 3, it'll make the denominator equal to 0. So what I want is all numbers except for negative 3 and 3. That means everything is okay up till negative 3. Everything between negative 3 and 3 is okay. And then from 3 to infinity, we're okay. Normally I'd write it in a straight line, but to try to get it to fit under 12, I put it there. So again, I found the problem spots and I only took those out. Everything else is okay. So everything till negative 3, everything between negative 3 and 3, and then everything after 3 was okay. So that's number 11 and number 12 domain. If I could recap that again, it'd just be to remind you that I'm looking for the problem spots and I'm taking them out. Okay, let's go down to the bottom. We're going to look at number 18 and number 20. Number 18 and number 20 are asking us to find the vertical and then the horizontal asymptote. So as a quick reminder, when we're solving, we find the vertical asymptotes by figuring out when the denominator is equal to 0. And then for horizontal, let's see if I can fit this in. When it's top heavy, so the degree on the top is greater, there's none. When it's the same, we do the leading coefficients over the leading coefficients. And when it's bottom heavy, so we talked about in class how if the fraction's heavy on the bottom, maybe it's like 1 over a million, so the million's heavy on the bottom. If I gave you a millionth of a cake, you wouldn't be very happy because it's practically nothing. So when it's bottom heavy, it's y equals 0. So that's a quick little recap for you guys. Sorry I keep going off the screen a little bit. Can't adjust the zoom once I start. So let's see if we can do number 18. For the vertical, I'm figuring out where the denominator is equal to 0. Well, the denominator is equal to 0 at 7. An asymptote is a line, so I need it to be like x equals for vertical or y equals for horizontal. For horizontal, let's look at the degree. Well, the degree of the top is 0. There's no x terms. The degree of the denominator is 1, which means it's denominator heavy. It's bottom heavy. So if I look at my rules, that means that my horizontal asymptote is y equals 0. Let's look at number 20. For the vertical, I'm figuring out where the denominator is equal to 0. Well, if I solve that, I get that x is plus or minus 3. For my horizontal asymptote, I look at the degrees. So you'll notice I have x to the 4th in the top. That's my largest. I should check all of them just in case it's not in order. I have x squared in the denominator. That means I'm top heavy. The degree on the top is greater. So that means I have no horizontal asymptotes, or I have none. There's a quick review of vertical and horizontal asymptotes. Okay. So I'm going to jump, I believe it was to number 24. So as a quick recap again, my y-intercept is what I get out when I plug in 0. My x-intercept is when my numerator is equal to 0. My vertical asymptote is when my denominator is equal to 0. And then this is when I look at my degree. So I'm going to call it, maybe I'll call it degree rules. So let's jump right in. If I plug in 0, I'm going to get 0 minus 2. So it's essentially minus 2. If I plug in 0 down here, I get 0 minus 6. So I'm really just left with that minus 6. So my y-intercept is going to be negative 2 over negative 6. I plugged in 0. That simplifies down to 1/3. So I plugged in 0. I got out 1/3. The x-intercept is when the numerator is equal to 0. So let's factor this. Remember, I'm just looking for two things that multiply to negative 2, but add to negative 1. Okay. Well, that's going to be a positive 2 and a negative 1. So my x-intercept is going to be at positive 2, 0, and at negative 1, 0. Remember, these are points, so I need to leave them in a format that looks like this. Well, the vertical asymptote is where the denominator is equal to 0, so I'm going to factor my denominator. Well, what makes the denominator 0? When x is equal to 3 and when x is equal to negative 2. Now I'm going to look at my degrees. This is squared, this is squared. That means they're the same. So this is when I look at my leading coefficients. The leading coefficient is just the coefficient in front of the term that has the largest degree. So the x squared is the largest degree term up here, and its coefficient is a 1. The leading coefficient in the denominator is going to be the coefficient of the x squared, which is also 1. And 1 divided by 1 is 1. So that's my horizontal asymptote. As soon as I filled in that information, I'm going to ignore this chart. I know a lot of you want to go to here next, but we're actually going to go all the way over here, and we're going to plot what I know. Well, I know that my horizontal asymptote is here. I know I have two vertical asymptotes. I have one at 3, and I have one at negative 2. Okay. Normally, I would not highlight my asymptotes, and I'd ask you guys not to do this on your paper, but because it doesn't show up well under, I think, on this video, I just want to make sure it's really clear that you guys can see where these are. So I'm going to highlight them, but that's not something that you should normally do. It's just to make it clearer in this video. So I hope you can see them a little bit better now. I didn't even highlight very heavy. Okay, so my asymptotes are in. Let's do my points. I'm at 0, 1/3. That's right about there. 2, 0. And negative 1, 0. So So remember, when I plot them, now that I've plotted everything I know, I need at least 2 points in each section. And if I have a middle section, normally I want 3. So on this side, so in this section of the vertical asymptote, I need at least 2 points. In this middle section, I need at least 2. And in this section over here, I need at least 2. Well, conveniently, I already have 3 in my middle section, so I'm really clear about the shape. It normally looks like a parabola, roughly, or like a cubic, but inside the asymptotes. This one's clearly turning back down, so I'm just going to connect the dots into a parabola-ish type shape. Well, I still need 2 points over here, and I still need 2 points over here. I like to pick something within 1 or 2 of the asymptote. I normally do, I'll do this first one, so we'll do negative 3, and then maybe negative 5. So let's do that really fast. If I plug in negative 3, I'm going to get negative 5 times negative 2. That's 10. If I plug in negative 3 down here, I'm going to get negative 6 times negative 1. That's just 6. Well, remember, we said if we don't have a calculator, we don't actually have to know exactly what this is. We just need to know what whole numbers it's between. If I double 6, I get to 12. So I know that this is less than 2, but greater than 1. It's between 1 and 2. So if I go to negative 3, I need to be between 1 and 2. So somewhere kind of in here. Okay, now let's plug in negative 5. If I plug in negative 5, I get negative 7 times, make sure I'm doing this right, negative 7 times negative 4, that's 28, over negative 8 times negative 3, 8 times 3, that's 24. So I notice 28 is really close to 24. This is just a little bit bigger than a fraction with a value of 1. So it's right going to be right about there. So I can tell that this thing up here is going to hug this asymptote, and then spin and hug this asymptote. That wasn't my best hug, but oh, now it just looks worse. Sorry, guys. Let's see if I can clean that up a little bit for you. I just want to make sure it's hugging that asymptote. This looks all sorts of special. Good enough. Okay, now let's look at this other section over here. Let's plug in 4. And then maybe 6. If I plug in 4, I get 2 times 5, that's 10. Over 1 times 6, ooh, I got the same thing again. One, 2, 3, 4, a little bit more than 1. If I plug in 6, I'm going to get 4 times 7, oh, I think we're going to get the same thing again. If I plug in 6, I'm going to get 3 times 8, that's 24. Yep, so again, it's just a little bit more than 1. And I'm just going to connect those. I'm going to hug that asymptote, hug that asymptote. That one looks better. So there's my graph. Looking for, I need at least 2 points in each section. And then you should be like correctly above or below, and then you're going to hug the asymptotes. So there's number 24 for you guys. Lastly, let's look at number 25. This is going to be one of our inequalities. So we've 4 steps. Sometimes we have a 5th. Let's look at the problem. So the first thing I need to do is get everything on one side. So step 1 says, let's move everything so it's on one side of the inequality. Step 2 says, let's get a common denominator. So that means this 4 needs to be multiplied by x minus 1 over x minus 1 to get that common denominator. Well, now I'm going to see if I can simplify a little bit. I'm going to have an x plus 4. If I distribute that 4, I get 4x minus 4. But I'm subtracting all of that. So that 4x is going to become a minus 4x. And that negative 4, once I distribute the negative, is going to become a positive 4. Okay, so let's see if we can simplify that. That's going to give me a negative 3x plus 8 over x minus 1. So now I need to figure out what's going to make those 0, right? So the denominator is going to be 0. So actually, we'll go through a step. So I need to figure out when the numerator is 0 The numerator is going to be 0 when negative 3x plus 8 is equal to 0. If I subtract the 8 and divide by negative 3, I'll get x is 8/3. And if I look at when the denominator is equal to 0, I'm just going to get x equals 1. So these two things here are what need to go on my number line. So that's going to be step number 4. So I have 1 and I have 8/3. So now we need to test intervals. Remember, everything on this interval should either be positive or negative. Interval should be positive or negative, and everything here should be positive or negative. So if I test just 1 point, that should be sufficient. So 0 is something that's less than 1, and I'm going to be plugging that into this simplified version. That was ugly. So if I plug in 0, I'm going to get 0 plus 8, that's positive, over 0 minus 1, that's negative. So this entire interval is going to be negative. Okay, 2 would be 6/3, so 2 is something safe to test on that interval. If I plug in 2, I'm going to get negative 6 plus 8, that's still positive. And if I plug in 2 down here, I'll get a positive 1, that's positive. So this entire interval is positive. I need to plug in something bigger now. 3 would work, 4 would work. We'll do 4 if you want. If I plug in 4, I'm going to get negative 12 plus 8. That's going to be negative. 4 minus 1 is positive, but a negative divided by a positive is a negative. Okay. Then I have to remember, well, I have a greater than or equal to sign, so I need to figure out if I need to include any of these or either of those points. Remember, if it's from the numerator, that's a 0, because if I plug in 8/3, I'll get 0 divided by a number. Well, 0 divided by a number is 0, and 0 is greater than or equal to 0. But if I plug in 1, I'm going to be dividing by 0. That's a problem. So since my 1's from the denominator, I don't fill it in. So I'm looking for all the places where it's greater than or equal to 0. That's this positive region. So I start at 1, and I go until 8/3. I do not include the 1, but I do include the 8/3. That is my answer. Okay. So there we go. We got through a couple, or at least one of each type. I hope that helped. I'll see you guys for your big quiz either on Monday or Tuesday. Good luck studying. Don't forget also there's an extra review posted on Blackboard. You're welcome to use that to help you prepare.